Welcome to the next session on secure processing environments. My name is Ulrich Sachs. I'm a medical informaticist by training located in Göttingen, and I'm heading the task area 3 of NFDA for Health, which is all about communication, networking, and so we're networking within Germany and in Europe. And we are very interested in how future analysis will look like. So it's next generation data analysis because we're all looking at the European health data space. And if you look in the legislation, so there will be more rarely some data transfer. There will be a login and a secure processing environment that you can work with the data. So, but our question, really pragmatic, was how does it feel? How does it look like? And we look at this from three directions, as before. So there's always the technical facet, which I think is the easiest. So we see three different generations of SPEs. So there's the one where you had to go and you had to show your ID card. They would let you in. There would be a computer, maybe a cup of coffee, and then you could work on the data. Was the first generation. Second generation would be virtual machines. So that's how I grew up with virtual machines. And it's still one provider, very enclosed, security-wise okay. Now we're seeing the third generation of SPEs coming up, which are cloud-based. Very, very interesting. Still, one question remains. How does a data holding organization feel about this change? So in former times, you would have your data set. It would be maybe even in your institute. And then people would ask for data use. You would have a use and access committee, and then you would all do this on your own premise. But this is changing now. So this is this part today. Today I'm happy that we got some really nice guests from the German Center for Diabetes Research, the DZD in Munich, and important Dr. Inau from Greifswald, reporting a long and really cumbersome story how data can be prepared for being discovered and for being checked in an SPE. So today, please come with us. We look at the data holding organization. We will have two parts today. First part will be a short introduction of the DZD, a very interesting German Center for Disease Research, one of many. We will hear from Dr. Lars Oest, from Angela Dedié and Ivona Anastasova. And in the first part, and then we switch to the perspective on how the data had to be prepared, how to build a data catalog, how to make it fair for findable, accessible, interoperable, and reusable, the whole journey. So this will be a podcast format, so we'll interrupt regularly in case I think there's something I have to ask. Otherwise, you in the audience are encouraged to have questions as well. I would ask you to put your questions in the chat, so I will sort them and then ask the question at the fitting point. So don't be shy, put your questions in the chat, and we will need maximum 1 hour. So that's why I'm already done. So without further ado, I would ask for the first presentation from Munich about DZD.
Yes, this is my part, and I hope you can see my slides.
Not yet, right?
Not yet.
Yeah, now. Okay. Please.
Okay, great. Thank you. Okay, so also welcome from my side. My name is Angela Dedié. I'm from the DZD data management team, and I'm here together with my colleagues Ivona Anastasova and with our team lead Lars Oest. So we are from the German Center for Diabetes Research, DZD, and the slogan of the German Center for Diabetes Research is Research for a Future Without Diabetes. And if we look at the numbers, we can see this is quite a challenge. Because diabetes is a global emergency. About 590 million people are affected by diabetes worldwide, and it's also a German emergency. Those numbers are from 2024, from the Deutsche Diabetesgesellschaft and the Robert Koch Institute. And here we can see that the diabetes prevalence in Germany is more than 10%. So about 9 million people in Germany are affected by diabetes, plus another 2 million who don't know yet, who are undiagnosed. And then there's the prediabetes prevalence, and this is another 20%. So most of those people are affected by type 2 diabetes, 95%, and type 1 diabetes is about 4%. And the total annual costs is about 21 billion euro. So what is the DCD doing, the German Center for Diabetes Research? The German Center for Diabetes Research was founded in 2009. There are 5 DCD partners spread over whole Germany and 5 associated partners and another 8 project partners. So altogether, there are 500 DCD researchers, and they are working interdisciplinary and translational. We have 10 multi-center clinical trials and more than 6,000 study participants, and those trials are about prediabetes, diabetes, and gestational diabetes. Then there's our training program. It's called DCD Next for young researchers. And very important is also the societal outreach. So we want to inform and to involve the public. Here are some highlights of the DCD of the recent years. The first one is about involving and informing the public, the German Diabetes Risk Score. This is free to everybody, where you can take a test and evaluate your own diabetes risk score at the DiabInfo website. It is about precision diabetology because, of course, there's more than just type 1 and type 2 diabetes. There are several subgroups. And at least it's about to have a precise treatment for each of those groups, at least for each individual. Then the early detection and prevention of type 1 diabetes. You might have heard of the FRIDA study. I'm sure you heard about the polyagonist. This is a new treatment, a new drug for the treatment of obesity and type 2 diabetes. The restoring beta cell function and the remission as concept for prevention in terms of type 2 diabetes. So those are the highlights, but now proceed to the data. The DCD data pipeline means we are collecting, processing, and analyzing the data. So here we are from the DCD data management team, and we work together with the DCD computational biology unit at Helmholtz Munich, and of course with all the bioinformaticians from the DCD partner sites. And there's also a use and access process for people from outside the DCD who want to work with the DCD data. So what data are we talking about? It's about clinical study data, epidemiological cohorts, preclinical studies, omics approaches, and real-world data. And let's have a closer look at the clinical studies part, because the DCD core data set is a very important part of the DCD clinical studies. It was invented in 2021. Right now we have 153 standardized parameters, and included is the DCG core data set. The DCGs, the German Centers for Health Research, contributed another 34 standardized parameters, and they are mandatory in all DCG clinical studies. Most of them are about diseases, so to make it easier to find cohorts across the several centers. So there's diabetes, of course, but there's also a center for cardiovascular disease, infections, lung diseases, mental health, and so on. So they work all together for the DCG core data set, and this is now part of the DCD core data set. So let's go back to the left side. The DCD core data set is mandatory in all DCD clinical studies, and the aim was to establish a community standard, a national or even international core data set for diabetes research. And to make this happen, it was clear that it is not sufficient enough to publish the DCD core data set on the DCD website. So we really wanted to have a fair core data set. And FAIRification means we wanted to make it findable, accessible, interoperable, and reusable. And this is when we came in contact with Dagmar Waltemath from the University of Medicine in Greifswald. And she introduced us to Inau, and we were really lucky that Inau helped us through the FAIRification process of the DCD core data set. And yes, with this, I would like to hand over to you, Inau.
One question in between
Yeah.
while you get this slide on there. So You're running since many, many years. So how would until now people apply for data use? They would know about DZD, and I think project internal persons. How would I, if I would be interested in the GLP-1 agonists right now, how could I apply for data use now?
Yes, we have a use and access process, and you can
Mm.
learn about it on the DCD website. And
Mm.
right now, you can apply via this process.
And what changed with the data catalog and the core data set? I think it's easier to understand and to grasp which things you are documenting in which trial. How was it before? So before it might have been quite erratic, right? That you have to know a researcher, then ask which data are you actually capturing? May I use it? May I be a collaborator?
Yes, well,
Mm.
all the clinical trials are published at the Clinical Trials Gov website. So you
Mm.
could already have searched there. Now they're also in the NFDI for a study hub. But the core data set, if you really want to know more about several parameters in the core data set, now they are really published openly. But this is already part of Inau's talk, so I don't want
Yeah,
to.
yeah, exactly. So I just wanted to point out the huge step you did by having this data catalog. And so, yeah, maybe I ask the other questions later because it's all about the five saves. This will be the recurring motive now in the next minutes about how project would look like, how you would check which people want to look at safe data, of course. How would you make sure that there's no or only limited re-identification risk? And so we're gonna hear this on the way. So you know, your part. Quite interesting story. Steps to bring data into the SPE data catalog.
Yeah. Yeah, so as Angela said, I worked on the verification of the core data set of the DZD, and I did that as part of my PhD, when I was doing my PhD, up until June at the Universitätsmedizin Greifswald. So the slides were made more than a month ago. So a little update that I forgot to include on this slide is that I'm now a postdoc at Universitätsmedizin Rostock. I started on Monday, so that's why it's still, okay.
Congratulations, yeah.
Thank you. Um, Next slide. Why aren't you going to? There it is. Um, so yeah, we have a lot of health research that has exponentially grown in the last few years, especially in the wake of the COVID crisis. And now we had to find a way to make this data fair because it was important, as per the COVID crisis really highlighted the necessity to make this data findable, accessible, interoperable, and reusable for both machines and human beings. Before that, it was estimated that the EU is undergoing costs of up to 10.2 billion euros, just by not having findable, accessible, interoperable, and reusable research data. Angela already highlighted that we have this clinical core data set that was established in 2021. It's got 147 data items across 8 modules. What you see on the screen is how the modules are divided. And the goal of my PhD work, or a significant part of my PhD work, was to verify these data items across the 8 modules. And so what I sought to do in collaboration with the DZD was to enhance the fairness of medical research core datasets through objective verification strategies. And then after that, we sought to employ and to compare the use of generic and health-specific verification workflows to verify medical research metadata. So these workflows had already been established by previous researchers working in the FAIR domain. And so now my work, in collaboration with the DZD, was to implement these workflows in the verification of this core data set, so that we can then compare what it is to implement, or what it takes to implement this verification workflows. What you see on the screen are the publications that came out as a result of this work. So we started with a baseline verification assessment, and a baseline verification assessment, a baseline fair assessment is whereby you check how fair is this data set at the beginning. So that then you can decide how fair do we want it to be and what do we need to do to get it to a fairer state, and what are the objectives of our verification in that case. Um, and then after that, we decide on the verification approaches based on what the fair assessment at the baseline is. And then after that, we do a final fair assessment to see what our verification approach is useful or relevant for the objectives. So before we could embark on a baseline and a final fair assessment, we had to choose which tool should we use. There's so many tools in the research economy right now that talk about how to verify or why this tool is better than the next tool. And we had to go on kind of like shopping or for tools. And we then came across an article by Kranz, which talked about how to choose these tools. And so basically the criteria or basically the shopping list for choosing a tool was the necessary prerequisite knowledge. Is it so much expertise required and does it provide guidance? And then the type of output of the tool. And does it show how to improve and to what detail does it show why the results of this fair assessment are the way they are and how they can be improved, and is it user friendly with regards to the type of input and the applicability of the tool. So these were the verification tools we had certified, which has since been discontinued. So that's also something that needs to be talked about, discontinuing of tools. Remember, these are projects for the most part, or the results of projects for the most part. And so funding is an issue, and regular updating of these tools is also something that needs to be considered when choosing a tool. We also have the one that was developed by the World Health Organization's HIP SAS. It's called the Human Exposome Assessment Platform for Self-Assessment Service. This was mostly developed for cancer research, but was still relevant for diabetes research. And then we also have the Research Data Alliance, and they developed the Fair Data Maturity Model. And we have one developed by the Australian Research Data Commons Fair Self-Assessment Tool. We ended up choosing the Research Data Alliance tool, the FDMM. That is the Fair Data Maturity Model because of its community recognition, its granular assessment, its clear interpretation, and its proven track record. So what you see on the screen is the output, basically how it presents the result. So it presents the results on a radar chart that ranges from 0 to 4, and 0 would be not applicable, 1 would be not even being considered, 2 is under consideration or in planning, 3 is in implementation phase, and 4 is fully implemented.
Sorry, could you here? I like this a lot because I think every data source being checked in or being discoverable should have a fingerprint like that. So would that be doable? Because here you see, I guess this was the process in the beginning, right? The findability, you see that number F2 was done correctly, F1 could have been better, F4 was not done at all, right?
Yes.
So how long would it take to assess a data source according to this? The same would be true for an A, for the I, and for the R. So you would have a fingerprint of a data source, right?
Yeah, that's true. How long it would take? Wow.
To assess it. So and usually I think it's a before and an after, right? He looked in before and then everyone said, "Oh, we have to do something for the F1. It might be the DOIs to be improved." Usually that's what's happened. Then there's a second round and you say, "Now it's improved F1 and improved F4."
No, that's not how it In
Okay.
theory, yes, but
Yeah.
when you're doing it, you will find that you will do a baseline 2 or 3 times over
Mhm.
because you're not like I was doing it in collaboration with the DZD.
Yeah.
So I have this result and the DZD has that result, and then we need to come and sit down and discuss results. And sometimes you agree, yeah, that makes sense. Sometimes you completely don't agree because you have different
Yeah.
understanding of fair, which is also something that scientists need to talk about. What is our understanding of fair?
It's
And one
true.
of our
Mhm.
objective, it sounds great when you say you just do a final and a baseline, but in real sense, you could do 6 or 7 um, before you get to a result that you think is
Yeah.
agreeable
Yeah.
with all the
Okay.
stakeholders.
Yeah. Thanks. Just for how to read those graphics. Yeah, I like them a lot. Yeah. Okay.
So the verification workflows, this is the generic verification workflow. You basically identify the verification objectives in collaboration with the data owners, the fair doers. You sit down on the table and say, we want to do this, and we want this to be the result of our fair. And then we analyze the data and the metadata. And then we define a semantic model and the metadata model. And then we make the data and the metadata linkable, we host it, and we assess. The verification process is gradual and iterative. So you're going to revise this over and over again. We call this the generic workflow because it is flexible for a diverse set of data sets. This has been used for nanotechnology, for example. It has been used for oceanology. And in this work, we used it for diabetes research data. And then another researcher came, he's called Sinachi. He came and he developed this one, which is more specific for health research, because health research is more sensitive and has more specific restrictions. We've got more technical and ethical and legal considerations when it comes to matters health research. And the difference in this case is that we have, or rather the most significant one is that it's pretty much similar to the previous one, but in this case, we've got the step of data de-identification and pseudonymization. We've also got a more distinct step of licensing and of licensing attribution. Um, and again, it's also iterative and gradual. So the baseline fair assessment, these were the results. Um, Somebody called this data anemia. So yeah, it was anemic pretty much because, kind of dismal at first. We didn't have a persistent identifier or registry index. We had very minimal metadata, a title and contributors, no biomedical and ontology annotations, no license for reuse, no provenance or version history. So yeah, basically just not very good scores.
But I
Um,
think that's very normal. I think 95% of all data baseline assessments would look like that because people would say we didn't need it yet, so a license is complicated. So for our internal use, that suffices. So,
mhm.
but I agree. So if you want to share data on a broader basis, this has to be done. This is quite an effort, and so. This is the fingerprint I was talking about. So this would be the baseline fingerprint, but now the story goes on. Yeah. So
That's true. First time, this is a common result. And I must commend my collaborators for being brave enough to talk about this. I feel like in my work, in my experience, I came to learn that there's some kind of, I don't know, shame or stigma or blah, blah, blah about being able to say, this is our result and it's not fair. Data owners typically have a big issue with, just saying this is our data and it's unfair or it's with regards to fair. But yeah, my collaborator said, yeah, sure, publish it. That our data is not fair. And then after that, publish the journey, which I guess is the most significant part or the more important part that we worked towards bettering it. And we were able to. And how did we do that? Well, a big part was implementing these workflows. And so when we selected the Fair Data Repository, which is also something that's another story in itself, where we had to go shopping for fair data repositories. But the good thing is that the Swiss National Science Foundation has a selection of repositories that they have already identified as fair. And then we selected the FAIR, and so we chose one just from the list, which ended up being the MDM portal. And then we selected a FAIR assessment tool, which I've already highlighted as the RDA FDMM. And then we performed the FAIR assessment, which you've seen, and then we identified the FAIRification objectives. We added unambiguous terms to the metadata. We registered it in this portal, the MDM portal, which provided for versioning and DOI assessment and indexing. And then we registered the metadata and SOP in Zenodo, which also provided for versioning, DOI, and provided the indexing and the metadata and SOP as a TXT file. And then we linked the DOIs on the MDM portal and Zenodo to a machine-readable metadata. And we merged and validated the final codes, which we achieved by semantically enriching the data items with SNOMED and LOINC and the UMLS, which also provided for bottom-up standardization. One thing that I have to say was a big help was that the expertise was readily available, which also I think is something that could link to Uli's first or second question. Can't remember. How long does it take? That also depends on how much expertise do you have available. In this case, it was pretty straightforward because the DZD had intentionally made expertise available for this exercise. So, after all of this, I think we could talk about a shortcut to fairyland. This is just a short bit, 9 steps here. It's just a short bit of the journey it took. But if you look at the publication, it's more than this. It's more steps than this. But the shortcut, something that I thought would be useful is, what if we could just say shortcut for beginners or shortcut for people who don't have that much time? So what you see on your screen is what it looks like on the medical data models portal, the MDM portal. We need a shortcut because not everybody has expertise readily available, time and resources readily available. So basically what you need is fair infrastructure. So as I said, the Swiss National Science Foundation has already identified fair infrastructure. So you could look up that infrastructure on the list and choose one according to your needs and your objectives. But in our case, we chose the one that provides standard terminologies, persistent identifiers, rich metadata, and registers it in preprint services in a preprint server that allows for DOI and versioning. Also something that provides versioning and provenance and qualified references and a searchable data repository. So before and after, were our efforts worth it? This on the screen shows a great recovery, I would say. Well, I did.
It's amazing if you look at the I and the O. Awesome.
Yeah. And I also have to say that what you see as not being achieved are not achieved because these are indicators that would require us to have data. And since this is still just metadata, we've not yet, at the time when this work was being done, we had not yet got any data for this work. So the metadata that have achieved 0 were not applicable in this case. Otherwise, we would have all 4s. Yeah, it took a period of time to be able to achieve this. I would say, maybe I think it took like 6 months or something, 6 to 8 months. And that was when we had all hands on deck. Now I've done this with clinicians who did not prioritize this work. Clinicians are busy people. They have got clinic things to do, and it took about 2 years. So is expertise readily available? Big deal. So summary of experiences. I came up with a shopping list. And this shopping list basically talks about what do you need to start your FAIRification journey. You need openness and willingness to accept that FAIRification is gradual. We don't achieve 100% in one day. We achieve 10% and then 20% and then 50%. And achieving more than 70% is already quite significant, is already, in my opinion, something to write home about. Collaboration from pertinent stakeholders throughout the data life cycle. And it would be great if we could think verification right at the beginning as opposed to at the end. So we could do it prospectively as opposed to retrospectively. But that also requires collaboration from the pertinent stakeholders.
Yeah, but
Financial support.
that's a good point because I always say that the most important people are the form builders, the people building the forms for capturing data. So and I think I did this myself, and I know which failures I had in doing that. So what's your assessment? Or maybe the others could answer as well. So would this journey have been shorter if from the beginning on the forms would have been annotated with metadata? Something which with a lot of effort had to be done afterwards. So would you agree, or would you say, we didn't have the time to do upfront, it was good enough to do it afterwards? Lars is already nodding, so I guess.
Mhm. And I know that the DZD has plans to do it prospectively for their next project. I think it's called Life Cycle or Life something.
Oh,
Yeah,
nice.
so I think they're really,
Hmm.
implementing the lessons learned from this process. Financial support, remember, expertise requires finance to implement, and a shift in organizational culture and workflows of research institutions. So,
Okay.
for example, annotating the data right at the source, so as Uli said, at the data capture stage.
I think Lars wanted to tell something. He was impatient.
Okay.
No, I'm not impatient, but you're absolutely right. I mean, setting up the forms is very important, and we are working on this front, definitely supporting our clinical studies, optimizing this. And we are happy that for our DCT core data set, for instance, one of us, Ivona, has been able to also getting international codes for the so-called Becker score. I mean, we do not have so many um, uh, form parameters in our DCT core data set, but we are definitely working on it. It's an important topic. I don't know, Ivona, if you like to comment.
Yeah, definitely. So it's very important, or an ideal situation would be when you set up your forms to already have standards in mind. So, for example, to look, okay, how is this represented in SNOMED CT? How is it represented in LOINC? How can I represent a concept that I want to include in my study in the most standard way possible, so that you avoid creating highly study-specific variables, which are then very hard to semantically annotate afterwards using already existing codes in SNOMED CT and LOINC. But then it's also very important to set your own standards. So, for example, what we've done is request some SNOMED CT concepts for concepts that are important but hadn't been semantically annotated before, or request the Baker score, which is a 27-item questionnaire, which is broadly used, globally used, but there were no LOIN codes available. And these are supposed to arrive in this month's release of LOINC. So yeah, that's also a very important part of making your data set interoperable and keeping it current.
And now the dangerous question, could you use anything from the MDM portal? So I use it a lot for teaching, I must say, and I like the DZD forms because most of them are nicely annotated. You just click on it and you see the LOIN codes or the SNOMED CT terms next to it. This would be desirable, right? That you could. Okay, a little advertisement. So I put the link in the chat so everybody who doesn't know it, please register and use it and upload your own forms that they can be reusable. And give 5 stars if you like it. So that the form, yeah. Okay, thanks for this little interruption. So, the story is not done yet.
Yeah. Just a little side note. For codes that are not available, especially with LOINC, the registrar encourages that we report that so that they can come up with codes. So I'm just letting the audience know that they actually take your reports pretty seriously, and they do come up with the relevant code for the next version, or at least they do their best. That has been my experience. So the core data set is now fairer and open. And I think that's something that people need to probably, or that is less understood by people. People tend to think that if it's fair, then it's going to be closed, or if it's fair, then it has to be open. Fair and open are not the same concept. Neither is fair and closed. Those are different concepts, and you're allowed to apply the license that is relevant for your specific kind of data. So you'd find some people who do health research not tending to be interested in FAIR because they think then their data would have to be open, and yet it's very sensitive data. That's not the case. I think scientists need to be educated on that matter, that just because it's fair does not mean it has to be open. Neither does it mean it has to be closed. You're allowed to choose the applicable license. Yeah, so it is necessary to, or it may be necessary to develop these tools, if possible, to accommodate data standards and frameworks that are supported by more interoperable frameworks such as HL7 and FAIR. And then it also may be necessary to establish key performance indicators so that we can see what exactly are the benefits of this work. We know we're fairer, and we want to know, so now that we're fairer, what? And how is that measurable, the benefits of this work? Right now we just have radars that say now we score 4 and before we scored 0 on this. But then what? Then what? What does that mean for the core data set in the long term? And I think this work has properly demonstrated the importance of evaluating the suitability of a fair assessment tool in whichever context you are in before starting a FAIRification endeavor. Something that so we know that it is costing the EU research economy up to 10.2 billion euros, at least in 2019, per annum, for having unfair data. It would also be interesting to know what was it costing the DZD before, or in your context, whichever context you're in, what is it costing you before, and how much resources have you saved just by FAIRification? Those are my references.